Today, we're diving into a new AI model called SAM-3. And look, this isn't just another small update. It's a huge leap forward in how computers see our world, understanding images with, well, pixel-perfect precision.
But to really get what makes this new model so special, we've got to ask a basic question. How does a computer actually see a picture? For a long time, it was just about drawing a box around something and slopping a label on it. Cat, car, you know the drill. That's a pretty shallow way of seeing, isn't it? And this right here is the big difference. A regular AI might just say, yep, that's a whale. But a truly advanced one can trace the exact boundary of that whale, down to every single pixel. This is called segmentation. And nailing this is the key to unlocking a much, much deeper way for AI to see.
And that brings us to the star of the show, SAM-3. This isn't just another step up, it's on a whole other level, opening doors to some pretty wild new possibilities.
So what does this actually look like? Well, take a simple scene like this. It's not just spotting kittens, it's isolating the exact shape of each one, even where their fluffy little fur overlaps. That level of detail is just incredible.
And its power isn't just for cute photos. Here, it's analyzing a microscopic image, perfectly outlining these tiny little organisms in a super crowded sample. I mean, just imagine the countless hours of tedious work this could save scientists. And this is where it gets really serious. In something like medical imaging, this kind of precision is absolutely critical. SAM-3 can pick out and segment very specific parts of the body, like the sacrum and hips in this scan, with an accuracy that's just wow. Okay, now look at this. It can take a cluttered, kind of chaotic industrial scene, a warehouse, and just make perfect sense of it. It's outlining everything from the people and the truck to the individual lights and even the metal panels on the wall. The sheer range and accuracy here is really what makes SAM-3 so powerful. So, how in the world is this possible? Well, it's not magic. It really boils down to two key things: a mind-bogglingly huge data set and a brilliantly simple idea in how the AI is built. First up, let's talk about the data. The best way to think about the dataset used to train SAM-3 is like the most complete visual encyclopedia ever made for an AI. To see with this kind of detail, it had to first learn from a truly unprecedented amount of information. Let's just start with the raw numbers. The core model was trained on a high-quality set of 5.2 million images. That is a vast and incredibly diverse library of, well, our visual world. And it's not just the number of pictures. Within those images, there were detailed notes for 4 million unique concepts, or what they call noun phrases. So this means it didn't just learn what a dog is. It learned about a golden retriever catching a frisbee in a park, and millions of other specific situations. This chart really puts it all into perspective. Just look for that purple circle way up in the top right. That's the data set for SAM-3. You can see how it completely dwarfs other big-name datasets, not just in the number of images on the side, but in the variety of concepts along the bottom. That massive scale is a huge part of the secret sauce. But you know, having tons of data isn't the whole story. The second pillar is a genuinely clever tweak to the model's internal design, which makes it way more efficient and a whole lot more accurate. It's this thing called the presence token. Think of it like a smart bouncer at a club. Before the model wastes any energy trying to find the exact pixels of an object, the presence token does a quick, easy scan of the whole image to answer one simple question: is the thing I'm looking for even in this picture? So the whole process gets broken down into two very logical steps. First, the presence token just recognizes if the thing exists anywhere in the frame. Only if the answer is yes, does the model move on to the harder job of localizing its exact boundaries. Separating the what from the where is a total game changer for speed and accuracy.
Okay, so it's a master at understanding a single frozen moment in time. But the real world moves, right? So let's see what happens when you apply this powerful vision to video and to some really complex thinking.
Now, this is really cool because it understands objects so deeply it can follow them through a video. It just knows that the pink kangaroo on the right is the same one from the left, even though it's moved and changed its pose. It gives objects a persistent identity over time, which is huge.
And this is where things get truly futuristic. When you combine SAM-3's powerful eyes with the reasoning brain of a multimodal large language model, you create something totally new: the SAM-3 agent.
It's an AI that can not only see, but can also think about what it's seeing and then decide what to do next. To make that real, the agent has a set of tools it can use. It can decide to find every single instance of an object, check out each one individually to make sure it's the right thing, and then select the correct one as the final answer. And if it finds nothing, it can report that too. It's a complete system for seeing, thinking, and acting.
All right, so we've seen the what and the how. But let's zoom out for a second and talk about this so what. Why is this such a big deal, and what does it really mean for the future?
The impact here could be enormous. In science, it could automate boring stuff like counting cells or tracking animal populations. For all you creative people, it means next-gen photo and video editing tools that understand scenes in a way we've only dreamed of. For robotics, it helps machines see and interact with objects with almost human-like precision. And even for AI safety, a better grasp of the visual world is a massive step forward.
If you remember one thing from all of this, let it be this idea right here. We're watching a fundamental shift. AI is moving on from just being a labeler, a system that just names things, to becoming a true perceiver, something that understands the physical space an object takes up and how it relates to everything else around it.
And that leaves us with a pretty fascinating question to chew on. As this technology gets better and better, and AI gets the power to see our world with perfect pixel-level clarity, what are the next great challenges we're going to ask it to solve? What will we want it to see next?